Hello students, this is Dr. Prakash Y, so Associate Professor in Physics. So now in this video, I would like to discuss the physics syllabus, okay, according to NEP. Okay, just I am sharing the PDF copy of the syllabus released from Bangalore North University. Okay, Bangalore Uttara Vishwavidyalaya means it is Bangalore North University. So this syllabus is based on NEP, as I told, choice-based credit system. Okay. So now this is implemented, as you can see here, 2021-22 onwards. Okay. Now, so in this PDF copy, clearly it is mentioned that the syllabus for first and second semester for physics papers. Okay? For B.Sc students, undergraduate means it is for B.Sc students. Now, this syllabus is framed by some certain university board members. Okay, you can go through them names here. So, Vijay Kumar H. Dudumani was the chairperson, and then it is followed by some members like Jagadish KN, K. Srinivasan, R.S. Molidhar, Madhusudan, K.T. Viranjanaya, E. Kalavati, and Anuradha P. So, now let us go through the detailed part of the syllabus. Okay, as you can see that already in the NEP syllabus. Okay, so if we consider the progress of the degrees as per as it is mentioned here, progressive certificate, and it can be considered as diploma, or it can be considered as bachelor's degree or bachelor's degree with honors, right? So certificate course means it is upon the successful completion of the first year. That means only 2 semesters of the multidisciplinary 4-year undergraduate program. Suppose if the student completed only 1 year, then they will get the certificate course. Suppose if he completed successfully second year also, okay, that means 4 semesters, he will get the diploma. Okay, similarly, if the student completed third year, that means 6 semesters, then so he will get the basic bachelor's degree. So similarly, suppose if the student is able to continue and complete the 4 years course, that means total will be there for 4 years, then the student is going to get the bachelor's degree with honors. Now, master's degree in discipline, so that is also possible in this NEP syllabus at the successful completion of 5th year. That means totally 10 semesters of the 5 years integrated master degree program. Okay, so some certain aims and objectives of the UG program is mentioned here according to NEP for physics. So just I will skip that conditions. So because my focus is to discuss the physics syllabus here for degree students. So the major discipline, if the student choose the major discipline as the physics as one of the major subject, then what may be the syllabus party? Okay, so you can see here semester wise the titles of the papers will be like this. Semester 1, so discipline core theory, coding is like this, physics DSCT 1. Okay, the title of the paper, the core paper title is mechanics and properties of matter. For second semester, the title of the paper will be electricity and magnetism. For third semester, wave motion and optics. For fourth semester, thermal physics and electronics. For fifth semester, so classical mechanics and quantum mechanics and elements of atomic molecular physics. Like that, there are 2 papers in the 5th semester. And similarly, in the 6th semester, again, there are 2 papers. Elements of nuclear physics and nuclear instruments. Second paper will be elements of condensed matter physics. Okay. So next, if I go to 7th semester, okay, that is for master's degree. So mathematical methods of physics, classical electrodynamics, experimental methods of physics, research methodology. Okay, so this syllabus is equivalent for master degree. Suppose if it is considered in the 4th year of the, and it will be under honors degree. Okay, so even semester 8 also comes under honors 4th degree of the B.Sc. So consisting of the syllabus like classical mechanics and quantum mechanics, statistical mechanics, astrophysics and astronomy, research project. Okay, so these 7th semester and 8th semester portions are equivalent to postgraduate MSc first year equivalent. Okay. So ninth and 10th semester, that is last final year MSc degree, is consisting of the syllabus like mathematical methods of physics is one paper and research project. Okay, in semester 10, okay, that is consisting of the two papers again, quantum mechanics 3 research project. So this is the titles of the papers only what I mentioned here. Now, so in any B.Sc degree, so major physics and also it is possible to take some open elective subjects. So from physics part of view, so what are the possible open electives that also we can go through here. For first semester, it is possible to choose open elective 1, OE1, that is energy sources. That means even major physics students also can choose this energy sources subject as open elective. And second open elective is physics for all. Okay. So this physics for all is only for those students who are not taken the physics as major. Okay. Other than physics students can choose this physics for all. So not only B.Sc students, even BA and BCom students also can choose this physics for all. Okay, except physics students. Physics students can choose only open elective 1, that is energy sources, during the first semester, along with their major physics subject. Any one of these, okay, OE1 or OE2. And now let us see for second semester. For second semester, open elective possibilities are, again, there are two, OE3 and OE4. So atmospheric science or sports science. So any one of these two can be taken by the students as open elective subject. Similarly, in third semester, optical instruments is OE5, elements of astronomy and astrophysics is OE6. So any one of these two can be taken as open elective during third semester. Now, if I go to fourth semester, okay, student can choose any one of their three subjects here. So like OE7, medical physics, OE8, nanotechnology, OE9, electrical instruments. Okay. So this is all about the open elective subject from physics side. Now I will go directly to the major syllabus part for physics students. Okay, those who have taken the physics as major during the B.Sc, along with other one of the subject like chemistry, mathematics, computer science, anything may be there as major. Okay, so but physics should be major during the during the B.Sc course. So what is the major syllabus for physics? So that is called PHY DST1. As I told, the title of the paper will be Mechanics and Properties of Matter. Okay. So the course content is like this. So actually it is consisting of 4 units. Okay. So in that unit 1, so each unit will be 13 hours of teaching, okay, including 3 hours of activities and problems are to be worked out from each unit also. Okay. But to understand, total teaching hours for unit 1 is 13 hours only. So in that there may be number of chapters. Now let us see what are the chapters in unit 1. So you can look at here, chapter 1, that is units and measurements. So in this small chapter, so portions, what are the portions to be covered? So look at here, system of units. Okay, we will discuss the system of units in both CGS and SI units. Measurement of length, mass and time, dimensions of physical quantities, dimensional formulae, okay, and mean deviation, errors and types of errors. Okay, so this is the content of the first chapter. So that should be completed in teaching hours of 2 hours. Okay, now chapter 2. So that is title of the chapter 2 is momentum and energy. So content of the momentum energy is again for 2 hours of teaching, consisting of work and energy, conservation of linear momentum, conservation of energy with examples. Okay, now look at the third chapter. So title of the third chapter is frames of reference. So in which the content is as follows, like inertial and non-inertial frames, Galilean transformation, principle of invariance, accelerated frames, and Michelson-Morley experiment. And then it is followed by next chapter 4. Okay, continuation of this theory of relativity will be there. So special theory of relativity is the title. of the chapter. So in which the content is Lorentz transformations, constancy of speed of light, postulates of special theory of relativity, Lorentz transformations and its equations, okay, length contraction, time dilation, relativistic addition of velocities, mass energy equivalence. Okay, so after these four chapters, okay, unit 1 will be completed. So next topics for self-study is there, of course, for students after completion of the first unit. So about variable mass problems or rocket motion, twin paradox examples. Okay, that is not necessary to discuss in the classes. You can leave it for students for self-study. And related to this unit, again, the syllabus suggests that so you can conduct some activities. Okay, suggested activities are like this. Okay, for example, measure the diameters of small balls of different size. Okay, measure the volume of a liquid, measure the distance and put the result both in CGS and SI units. Estimate standard deviations wherever it is possible. And similarly, activity 2, understand conservation of energy in everyday examples, like what happens in solar energy conservation panels. Pushing an object on the table and moves. Moving car hits a parked car, causes parked car to move. So these kind of activities can be discussed and can be done during the lab hours. Okay. Okay. Now let us see what is the content for unit 2. So again, as I told, it is also 13 hours of teaching. And the next chapter is chapter number 5 in unit 2. So the title of the chapter 5 is Laws of Motion. Okay, the content is very simple here. So Newton's laws of motion, dynamics of a single particle, and a system of particles, center of mass. The next chapter is dynamics of rigid bodies. Okay, the content, rotational motion about an axis, related relation between torque and angular momentum, rotational energy, moment of inertia. Okay, so with some examples like moment of inertia of rectangular lamina, solid cylinders, flywheel, theory of compound pendulum, and determination of acceleration due to gravity, that is G. Okay. Next chapter is called gravitation. So in which the laws of gravitation, motion of particle in a central force field. Okay, so in which motion in a single plane and angular momentum is to be focused here. And then aerial velocity is also constant. Okay, that content should be discussed under the motion of particle in a central force field. Then at the end, Kepler's laws, only statements to be discussed, and satellites in a circular orbit. The concept of satellite in a circular orbit should be discussed in this chapter. Okay, after these 3 chapters, unit 2 will be completed. And again, it is followed by some self-study portions like geosynchronous orbits, basic idea of global positioning system, GPS, etc. And then the laboratory, some activities are suggested here. Okay, so that the students can be considered. The examples of moment of inertia is an abstract concept. To understand this abstract concept, so it is simply gives a measure of rotational inertia of rigid body, and it is proportional to product of square of radius r of the body and its mass m. Okay, refer to different websites to construct and perform simple experiments to verify the moment of inertia. Okay, so some reference also mentioned here. Okay, some websites are mentioned so that you can use these websites, help of websites, and understand the concept of moment of inertia. So that is one activity. Another activity, prepare suitable charts and give seminar talks in the class. Okay, so that can be done by the students. Okay, next unit 3. Okay, unit 3, chapter 8 starts with the chapter number 8. First chapter is elasticity. So I think in this some detailed discussion is there. Hooke's law, stress strain diagram, elastic moduli, relation between elastic constants, Poisson's ratio, expression for Poisson's ratio in terms of elastic constants, and then work done in stretching and work done in twisting a wire, twisting couple on a cylinder, and beam bending. Okay, expression for bending moment, theory of single cantilever. So this is the major chapter in unit 3. Okay, chapter 9 consisting of some portions again. Torsional pendulum, expression for time period of torsional oscillations, determination of rigid modulus and moment of inertia, the determination of Q, eta and sigma by Searle's double bar with necessary theory. Okay, so these two chapters to be completed under unit 3. And again, it is followed by some self-study portions like time period of oscillations of a spring mass system with non-negligible mass of the spring. Now, activities are also there. So arrange a steel spring with its top fixed with a rigid support on a wall and meter scale along the side. So add 100 grams load at a time on the bottom of the hanger in the steps. This means that while putting each 100-gram load, we are increasing the stretching force by 1 Newton. So measure the extension for loads up to 500 grams. Plot a graph of extension versus load. Okay, so this is some kind of laboratory experiment. But these activity works are not regular experiments for you. So at the end of the syllabus, I can mention what are the regular prescribed experiments for the first semester. So these are considered only activity parts based on the theory. Okay, in activity 6, repeat the above experiments with rubber, other materials, and find out what happens after exceeding elastic limit. Plot and interpret. Okay, so that completes the unit 3. Now let us see what is the portion for unit 4. So unit 4 starts from the chapter 10. Okay, so in the chapter number 10, the first chapter is surface tension. So definition of surface tension, surface energy, relation between surface tension, surface energy, pressure difference across curved surfaces, excess pressure inside spherical liquid drop, angle of contact, okay, with some examples. And then next chapter is chapter number 11. Okay, the title is viscosity. Streamline flow, turbulent flow, equation of continuity, determination of coefficient of viscosity by Pagel's method and Stokes method. So these are the two chapters in the last unit, that is unit 4. Okay, and in the at the end of the unit, topics for self-study is mentioned as natural phenomena involving viscosity and surface tension. So based on that surface tension viscosity, again you can do some activities. Okay, in the activity 7, so all based on the surface tension. You have to understand why water has high surface tension and check whether surface tension is a function of temperature or not. Okay, you can do it by heating the water to different temperatures and measure the surface tension. So plot the surface tension versus T and learn how it behaves. So this activity can be done, of course, in the laboratory. Similarly, in activity number 8, collect set of different liquids and measure their viscosity. So this activity is based on the viscosity, okay, so that you can understand how to find out whether sticky, the liquid is given as a sticky or non-sticky. Liquids are most viscous if they are sticky. If they are not viscous, then they will not be sticky also. Like that you can understand in the laboratory. So mix non-sticky liquid to the sticky liquid in defined quantities and measure viscosity. Find out viscosity is increasing or decreasing. Okay, so the increase of non-sticky liquid concentration. Okay, some activities are mentioned here. So that is the end of the 4 units for semester 1 for the students who have taken the major physics in B.Sc course. Okay, so of course to go through the syllabus, some textbooks also mentioned as per the NEP syllabus. So for mechanics, okay, authors are D.S. Mathur and mechanics and relativity, okay, the Vidwan Singh Soni, mechanics, okay, in SI units, of course, that is Charles Kittle and properties of matters, Bijlal and Subramaniam, okay. So these books are standard reference books for the, as per the syllabus. So textbooks and reference books are also there. Principles of Physics, David Halliday, and Physics by David Halliday and Robert Resnick. Okay, so this completes the first semester portion. Of course, now let us see what is the list of experiments to be performed during the lab for first semester. As I told, some list of experiments are there. Okay, out of the mentioned experiments, I think you have to mention, okay, a minimum of 8 experiments to be carried out in each semester. So there are totally 15 experiments mentioned here. Just go through that. Error analysis, data analysis, and graphing techniques to be learned. So this part of the study is very important for our students, and hence it is mentioned as mandatory. Okay, this first experiment is mandatory for all the students. And second experiments, determination of G using bar pendulum. Okay, and then determination of moment of inertia of a flywheel. Determination of rigidity modulus using torsional pendulum. The verification of parallel and perpendicular axis theorem. Determine the Young's modulus of a bar by uniform bending method. Determination of elastic constants of a wire by Searle's method. So Young's modulus by Koenig's method. Modulus of rigidity of a rod, static torsion. Viscosity by Stokes method. Verification of Hooke's law. Determination of surface tension of liquid and the interfacial tension between liquids using drop weight method. And critical pressure for streamlined flow. Determine the Young's modulus a bar by single cantilever method. Study of motion of a spring and to calculate spring constant G and unknown mass. So these are the 15 experiments are mentioned under the syllabus, but you need to perform minimum 8 experiments in this semester. Again, there are some reference books for laboratory experiments. You can go through them also here. Physics through experiments by B.Sc, a laboratory manual of physics for undergraduate classes by D.P. Kandelal, B.Sc Practical Physics by C.L. Arora, an advanced course in practical physics by D. Chattopadhyay. Okay, so I will complete. Okay, so this is the completion of the first semester portion. In the next video, I will discuss what is the content syllabus, core syllabus for second semester in physics. Okay. Thank you for listening and going through this syllabus.